Hi everyone, great to see you again. For those of you who might be new to the team, my name is Christopher Rowe, and I am the instructional designer for the Faculty of Business, Information Technology, Part-Time Studies, and London South Campus. Today's video is on the subject of cognitive load theory. This is a really big topic, so I'm going to split it into two parts. Part 1 will be a description of the actual theory and how we can use it to manage our students' capacity to learn. Part 2 will cover more specific instructional techniques that are influenced by the theory. No more wasting time, let's get right into it. What is cognitive load theory? Cognitive load theory, or CLT, was introduced by John Sweller in the 1988 article titled Cognitive Load During Problem Solving: Effects on Learning. However, the majority of the content I'll be discussing in this video was pulled from Sweller et al.'s extremely excellent 2019 article titled Cognitive Architecture and Instructional Design, 20 Years Later, in which the authors described the theory and how it evolved over its 20-plus year history. If you're interested in the subject, this is a must-read. I'll include it in the email I used to send out this video. In essence, CLT refers to the understanding that human cognition has inherent processing limitations when dealing with novel information. CLT looks to understand those limitations with the goal of informing the design of instructional material and pedagogy to optimize human learning. With that in mind, Sweller argued that the human mind has a limited capacity to process novel information in working memory before it can be stored in long-term memory. If we present learning material inefficiently, we expend some of that capacity on ideas that don't pertain to the topic at hand and thereby reduce the likelihood that learning takes place. Why is cognitive load important? Without an understanding of how humans process novel information, we're left with little direction on how best to present course content in such a way that increases the likelihood that our students will learn the material. So, it's in our best interest to develop at least an introductory level understanding of the human limitations on cognitive capacity so that we can optimize the presentation of our learning material. Intrinsic, extraneous, and germane cognitive load. So, how does it work? CLT is primarily concerned with the relationship between working memory and long-term memory. Working memory is where we process information and make use of it. Long-term memory is where we store it. CLT breaks working memory down into three categories. Those categories consist of intrinsic, extraneous, and germane cognitive load. Intrinsic cognitive load. Intrinsic load is directly associated with the complexity of the task to be learned. The greater the complexity, the more of our cognitive capacity is expended. Importantly, only novel information increases cognitive load. When we access information previously stored in long-term memory, there appears to be a limitless capacity to process it in working memory. This idea of unlimited access to long-term memory has a huge impact on effective pedagogy. More on that later. Extraneous cognitive load. Extraneous load relates to any environmental input that does not pertain directly to our understanding of the task at hand. This can take a great many forms and can vary drastically in the context of the learning task. What's important to understand is that extraneous load is a distraction from the learning task and should be avoided. Germane cognitive load. Germane load is the processing that occurs to actually make sense of novel information and integrate it with previous knowledge. Germane load represents our capacity to learn. How they work together. We have only a limited cognitive capacity, and the way each of the three previously mentioned categories interact with one another impacts our ability to learn. As an example, in a situation where the task to be learned is very complex, intrinsic load is increased. If we're working in a situation where extraneous load is also high, possibly through the inclusion of course content not directly related to the lesson, we're left with very little capacity for germane load, that which is responsible for learning, and so our ability to process that information, learn, and commit it to long-term memory is significantly reduced. With this concept in mind, to increase the likelihood of learning, we as educators should be mindful of managing our learners' intrinsic and extraneous load to allow for as much germane load as possible. We can manage extraneous load by being mindful of reducing unnecessary input from the learning materials wherever possible. This means we should be critical not only of the content we're including in our learning material, but also in the way that it's presented. This is one of our main objectives of instructional design, to reduce extraneous cognitive load wherever possible to increase our students' capacity to learn. We can also manage intrinsic load by being mindful of the order in which we present information in the context of a complex learning task. Here we have an example of a highly complex learning task that puts a strain on intrinsic load. As I mentioned before, our ability to access and process knowledge from long-term memory is seemingly limitless and has no discernible impact on intrinsic load. So, if we divide a complex task into manageable chunks, we can reduce the complexity of each individual chunk, reducing intrinsic load. We can then allow a learner to commit knowledge from an earlier, simpler chunk to long-term memory. That knowledge is then accessible during the learning of subsequent chunks and can be accessed without increasing intrinsic load. As a result, we can increase the complexity of the latter chunks, incorporate knowledge stored in long-term memory, and keep intrinsic load at reasonable levels. So, long story short, our goal should be to eliminate extraneous load wherever we can, reduce intrinsic load wherever possible, and engage the use of long-term memory whenever appropriate, thereby increasing germane load and our students' capacity to learn. I know that's a lot, so in the spirit of reducing intrinsic load, I think we'll call it quits for now. In the second part of this video, we'll talk about specific instructional techniques that can be used to take advantage of cognitive load theory and increase learning for our students. See you soon.